Welcome back. In today's episode, we are going to look at free body diagram, what we also call FBD. And the free body diagram is a way of identifying and taking account of all the relevant forces acting on a body in a given situation. We know that sometimes we can be given a diagram or we can be given a structure to calculate for the relevant forces acting on them. And most of the time, some forces are hidden. They are what? They are hidden. So we have to isolate them so that we can get a detail, we can identify and take account all the relevant what? Forces. And as engineers and as mechanical engineers, free body diagram is very important because one, it helps us to identify the what? The relevant forces and those hidden forces. Because looking at this structure, there are what? Some nuts or some bolts at A, B, C, some joints at A, B, C, and all these joints has forces what? There. How do we know those forces? We have to draw the free body diagram. The free body diagram also means we are isolating the structure. We isolate the what? The structure from its fixed what? Points. Its fixed point. This structure is a what? Is fixed at point A, point B, and point C. And at point C and A and B, there are forces what taking place. And we will see how to represent forces at what at joints like this. And when we look at this diagram, we can also make analysis only if we draw the free body diagram. We will look at how the steps to draw the free body diagram. The free body diagram of this will help us understand that here, at where the wheel B is, there is a force what? Taking place. There's a force taking place. So I'll take into account all these forces. For instance, if I don't draw the free body diagram of this, I will only know some forces as force P, maybe the weight of this, maybe the weight of that. I'll forget that there is a force also taking place here. But with the free body diagram, I'll be able to identify all the relevant what? Forces. And that's the main what? Idea of drawing a free body diagram. In questions like this, if you are to solve, the free body diagram carries huge mass and we have to do it. At this point, there are forces acting, there are forces what? Acting. And it's necessary we find out. It's going to be interesting. Let's look at how to draw some free body diagram. Let's look at this. We have this structure A and B, and this one is to help us draw our what? Free body diagram. Let's look at the steps involved. How do we go by free body diagram? First, you decide, you see this is body A and body what? B. You decide which body is under consideration and imagine it to be isolated from all the other bodies attached to it so that you sketch it alone. Are we good? So first, you decide the body under consideration. Under consideration. So sometimes, for example, if in this block you are to calculate for relevant forces on only A, then you are going to consider only A by isolating it from what? B. So you decide the body under what? Consideration. Sometimes the whole structure is not important to what? To calculate for all the hidden forces, but those in what? In consideration that we draw the free body diagram. We will draw the free body diagram for this body and we'll see how each force will what? Will be represented. If A is the one to be considered, or B is the one to be what considered. So after deciding which body is under consideration and you sketch the body, two, you indicate by means of arrows the external forces. So you indicate you're interested in the external what? Forces. External forces. So indicate the external forces using what? Arrows. Using arrows. Are we good? So you are going to use arrows to represent all the relevant and hidden what? Forces. And these forces should take into account those hidden forces should either be the weight. Remember this, the weight of the body. If you are drawing a free body diagram for any object, consider the weight. Unless the question says you should ignore the weight of the body and all the external what? Applied loads. So external loads, the reactions. So these are some of the things you should consider. Reactions is very necessary. So when we see structures which are fixed with what? Some bolts, some joints, some pivots, that place will carry some what? Reactions. And all the external loads should be also what? Considered. Then we consider the weight of the body. So looking at this, there's going to be a reaction here. We'll draw it and we'll see. There's going to be, if you are considering body B, there will be a reaction. And there will be what? The weight. We'll see how to also indicate the weight. Then the third point, what do we consider? Then you indicate the dimensions. Indicate, so it's necessary you know all this. You indicate the dimensions. The dimensions. You indicate the dimensions. And why are we indicating dimensions? Remember in the other episode, it was established that sometimes we will be getting three what? Unknowns. Unknown forces. Three unknown forces, and summation of force on the x will give us one equation, summation of forces on the y will give us another equation, and summation of moments will also what? Give us another equation, so that we can calculate for all the three unknowns. And calculating for moments, we need to know the dimension so that each force can be taken what? A moment about a fixed point. So we indicate the dimension to help us calculate for moments. It is necessary. Remember, moment is what? The force times the perpendicular what? Distance about a fixed point. So we go through these steps. Then the fourth one, what do we do? We use a letter and arrow to represent the magnitude and direction of each unknown force. We use arrows and letters to represent unknown forces. So something like unknown force, the weight, you are going to represent it, maybe you can say W. A reaction at A, you can say RA. A reaction at B, RB. Are we good? And we are going to use arrows to indicate. So for example, we'll draw this and you will see weight an arrow will come down and I'll say W as the weight. A reaction on top, I can use this arrow and say reaction at A, or something like this, reaction at what? B. We use arrows and letters to represent unknown forces, which is quite what? Interesting to understand how it works. So let's look at the fifth point. What do we do again? Now, if during analysis the magnitude of an unknown force turns out to be what? Negative, the negative sign indicates what? That you have chosen the opposite sense. For example, if I make my calculations and I see that my reaction at A is a negative, let's say 10 Newton force, meaning the direction shouldn't be this, it should rather come down. So you check for the sign of what? The forces, the sign of the what? Forces, and it will help you to know your correct what? Direction. It's very necessary. So let's look at how we can draw the free body diagram for this. So let's consider two blocks. We know A and B, and B is on the ground and A is on B. There are two what blocks, and we can separate them. So first, let's try to separate A from B and B from the ground. So I'm going to get something like this. So something like this for the A at this block. So block A and block B will be separated from the ground as well. So this is block B. They are separated now. Okay, so let's look at how we can indicate, so decide the body under consideration. The two of them, they are under consideration. So let's take the two of them. All right. So indicate the external forces using arrows. And those forces should include the weight, the external force, and the reactions. All right. So first, the weight. We know that A has what? Weight. And the weight of a body acts what? Perpendicularly downwards. So I can say this is, I'm using the arrows. Remember, it says use arrows to what indicate the forces. So weight is a force. So the weight of block A is coming down. So and indicate, we should use arrows and letters to represent the unknown force. So I'll just use weight. Weight of what? Body A. Remember, body B also has what? Weight. And it will also come down like this. Weight of body B. Are we good? All right, so we've now indicated the weight. What again? Do we have any external force acting on this? Any external force? There was no external force given. All right, let's look at reactions. Yes, is there any reaction going to happen? A reaction occurs when two bodies are in contact. So where two bodies are in contact, we get a reaction. So let's look at the ground for B. Yes, there's a reaction from the ground here. That's only affecting what? B. So I'll indicate that reaction, and it will be an upward reaction. Remember, the weight is bringing the block down, and the reaction will try to oppose it that way. Are we good? So I have a reaction. I'll represent it with an arrow and a letter. So I'll say reaction at what? Let's say reaction of C or G, reaction at the ground. Okay. Is there any reaction again where two bodies are in contact? Yes. Here at the surface of A and B, they are in contact. So there will be a reaction. Are we good? And how do we represent those reactions? Now A is separated. The weight is trying to pull it down, and the reaction here would pull it up. So I'll get this reaction. So reaction of A is trying to what? Pull it up. Don't forget that that same reaction will also happen to what? B. Because here B is also in what? Contact with A. So there will be a reaction here. And if this reaction is pulling this up, there will be a reaction pulling B also what? Down. So this will be another reaction. Reaction what? B. Are we good? So this is what we have as the free body diagram. So if I want to consider body A, I have the weight and reaction at what? A, two forces. If I want to consider B, you see there are three forces here: reaction at B, the weight of B, and the reaction of the ground. And it's quite interesting. We can establish formulas from this to help us what? Get the unknowns. Are we good? So let's look at it. If I'm looking at body A, can we say, do we have any force in the x direction, the horizontal direction? No. But we have force on the vertical, which is on the y. So can we say that my upward sense is positive, those down is negative? That the weight, since it is in equilibrium, the weight of A plus a negative Okay, so I chose the A to be positive or negative. Negative weight plus reaction at A should be what? 0 as one equation. Are we good? Then when we come to body B, let's choose all the downward forces negative. This is negative and this is positive. Reaction at the ground, which is positive, minus the weight of B minus the reaction of B should be 0 as one what? Equation. So these are the equations that we have. Are we good? So assuming we know the weight of A, we know the weight of what? B. Then it will be left with three unknowns: reaction at A, reaction at B, and reaction at what? The ground. These are bodies that we need to represent them with what? A free body diagram. And for instance, I have body 1, the second body, the third, and the fourth body. So in cases like this, what do we do? So if I want to represent this, the free body diagram of this, how would I represent it? Remember, this one has no what? Reaction anywhere, but it has weight and there's a support also here. There's a taut flexible cord or a rope tied to it. So I can just draw the free body diagram of this way. Remember, in the rope there's what? Tension force. So I'll indicate the external force, which is the tension force. So this will be the free body diagram. If I want to take into account the weight, the weight will act downwards, which is the weight, and this tensional force in the rope will also what? Come this way. Now it is at an angle, so I can have my free body diagram this way. So simple. The force here, or the tension force, and the weight of that. What about this body, which is on a smooth or a frictionless surface or contacting what surface? How do I draw my free body diagram? I can also say there is a reaction here. There's a reaction. I can also draw my diagram this way. Okay, so there's a reaction, when this is the ground, representing the ground or a surface. And when bodies are in contact, there is what? A reaction. So the reaction here, R, and maybe the weight coming what? Perpendicularly downwards. So the weight, which is W here, you get the weight. Are we good? It is what? Frictionless, so there will not be any friction. Suppose there was friction. If this body was sliding down, there will be friction what? Pulling it up in the opposite direction, but no friction given. Are we good? All right. So the fourth body, how do we also represent the free body diagram of this? So I can choose, there's a joint. And also we should know how to represent forces, or yes, forces at joints. How do we represent forces at each joint? Are we good? This is a pin joint. Are we good? We have a pin one. This is a ruler. Is what? A ruler. How do we represent the forces over there? One, if it is a pin, it is going to have two reactions in the x coordinate and in the y coordinate. And if it is a ruler, it is going to have an upward reaction. An upward reaction. Are we good? Let me indicate it here. So, assuming we are drawing the free body diagram of this bar AC, first we have to isolate it. It is the one under consideration. So I will isolate it. It is being what? Isolated like this. And I'll indicate the external forces. Let's neglect the weight. So I have an external force already here, F, like this. An external force, F here. So I'll also consider the reactions. Since here is a pin, it's a pin reaction. Anytime you see a pin reaction, it is going to be a pin on a structure. The reaction is going to be 2. So you're going to have an upward reaction, a reaction in the y direction, and a horizontal reaction, a reaction in the x. Whenever it is, so here is A, let's consider B here and C. When it is a ruler, we are going to have an upward reaction. So this is a ruler at B, only one. So RY2, this is Y1. And there's another ruler at C, which is going to be an upward reaction, RY what? 3. So this is the free body diagram of that. And if there were dimensions given, we would have indicated the dimension to help us calculate the relevant moment. Are we good? So free body diagram means detaching the body from its surface, from its support, and indicating the reaction. It's very simple. For example, if I want to draw the free body diagram of this car, it's going to be interesting. So let me represent something small here. So I have something this way. I have the car. It's just a representation of the car. So let's say this way. I have my car and I have my this box C and D. So there's this box C, and box D this way like this, box D. And there are wheels and the G of the car is here. So let's look at it. Any external force here, there was no given external force, but we can also see that the weight of the car acts at G, the center of gravity. So I can represent it here. The weight of the car. What about the wheels? The wheels represent a roller. You see that it is not a fixed point, it's a roller. It is rolling on the ground. So it is going to be an upward reaction at A. So let's say here is A and here is what B. So there will be an upward reaction. So reaction at A, and there will be an upward reaction at B, the roller again. What about the boxes? They also have weight. So far as there are boxes here, there's a weight. So there will be the weight of the box C, and there will be a weight of box D. The weight of the car is represented. So basically, this is the free body diagram of the car where we indicated all the relevant forces. Their dimensions were given. So the dimension of this is 1.7 meters between C and the end of the car is, you indicate the dimension, is also 2.8, and between B and this place is 0.75, between that 1.2, and between this is 1.8. So this dimension will help you to find the what? The moment. Remember, we don't know reaction at B, we don't know reaction at A, and we don't know the weight of the car. Assuming we know the weight of the boxes, we'll get 3 unknowns here. So forces upwards, forces downwards, and we also consider moment as a third equation to help us understand or get our relevant forces. With this, I know you've understood how reactions are being what? Taken, and how we also draw free body diagram. We'll be solving examples in the next episode, and we'll draw the free body diagram for each problem, and it will be simple for you. Thank you for watching this episode.